All right, I'm going to quickly explain the nonlinear load, the one that I've built. So the way the nonlinear load works is there's an AC supply, which is 24 volts peak to peak, which is applied over a 10 ohm resistor, which is over here, which is being pulsed on and off by these two MOSFETs. This circuit over here is to ensure that the pulse of these MOSFETs is in phase with the input voltage. I'm not going to go into detail about how that works. But once this is switched on, I've got the voltage over the nonlinear load and the current through the nonlinear load over here. So if we go to the oscilloscope, then you can see the purple trace is the current over the nonlinear load, and the blue trace is the voltage over the nonlinear load. And the voltage is distorted because of the distorted current that's being drawn. So if we look at the current spectrum, or the frequency spectrum of the current, let me just set that up, go to the harmonics. This takes a while. All right. Then this is the frequency spectrum of the harmonics. And as can be seen, it's the 3rd, the 7th, and the 11th harmonics which are the most prominent. And those are the ones which I'm going to try to mitigate using. All right, I'm now going to explain how I'm going to add the filters, the parallel passive harmonic filters, across the nonlinear load in order to mitigate the current harmonics, which you can see over here. So these are the current harmonics I'm going to be mitigating by applying these passive filters which I've designed. So the first one that I'm going to apply is for the lowest harmonic, which is the 3rd harmonic. And the way I do that is by putting this inductor here in series with this capacitor, which is then in parallel over the nonlinear load. So if you look at the frequency spectrum, when I apply this filter in parallel, all right, so I've applied the filter, and you can see how the current harmonics of the 3rd harmonic have gone down significantly. All right, so I'll now apply the 7th harmonic filter, which is the 10 microfarad capacitor in parallel with this inductor here, which has been tuned for specific inductance. And if you look at the frequency when I apply that, come on. Okay, now it's been plugged in, and you should see that the 7th harmonic has reduced significantly. It's worth mentioning that it takes time for the spectrum analyzer to settle, so that's why sometimes after I plug it in, it's not instant, the change of the current. It doesn't drop down instantly. All right, so that's the 7th harmonic filter, and now I'm going to apply the 11th harmonic filter. It's not that relevant with respect to the spectrum, as you can see over there, but I modeled it in PSpice, and the 11th harmonic was still quite relevant or prevalent at that time. So I'm just going to apply the 11th harmonic filter now to show you what that does to the spectrum. So now the 11th harmonic filter, as you can see, is reduced. The amount of reduction is significant, but you won't be able to see it there because the spectrum analyzer hasn't shown much of the 11th harmonic to begin with. All right, so that's the addition of all the filters, the 3rd, the 7th, the 11th filters. And now to show you what the time domain current and voltage look like, this is it. As you can see, the current and the voltage are much more sinusoidal than they were before, which is the reduction of the harmonics. Now, one thing that's quite evident is that the current is leading the voltage. That's because at 50 hertz, the filters are primarily capacitive. And to fix that, what I've done is to place an inductor, which I have designed to have the same reactance as the capacitance of the filters at 50 hertz, and applied that over over the nonlinear load, which should fix this problem. So if you look at the spectrum, when I apply this inductor, you can see that they are almost perfectly in phase now. So that's the addition of the inductor, which is acting like most capacitors which are used for power factor correction, except now we're doing the opposite, we're adding an inductor. Yeah, so that's the entire system, and if we look at the current harmonics, after what I've called the compensation inductor has been added, this is what the current harmonics look like, and they've been significantly reduced. All right, yeah, that's it.